So now we will start about propagation of an action potential. So before going to discuss about the propagation of your action potential, how to generate an action potential. So the generation of your action potential. So by the three methods. So one is for the physically. So that is your first one is for the physically, and second one is for the chemical, and third one is for the electrical. So these three are the generation of your action potential. So what do you mean by the physical signal? So if you are applying any physical, so that is your, if you are applying the some force, if I am applying some pressure P, so then if you I am going to hit, or if we can applying some poke. Now these are the physical excitation to applying into a cell. Now second one is a chemical reactions. So body allows some substances to pass into the inside of the cell membrane, so such kind of like a food materials in sometimes. So food materials are not digest at that time, so it cannot be, so it will releases some gases, so through out of the human being body or human being mouth. Now it is a chemical reactions. Now third one is a electrical. So if you are applying some electrical excitations, electrical shocks into the human being physical body in hospital section, so these are the generation of your action potentials. Now we will move into now we will move into the propagation of your action potential general diagram. The propagation of your action potential general diagram here. So if you want to see here the outside of the cell membrane, so which will be present in the outside of the cell membranes. Now these are the Na plus ions inside of the cell membrane. So now this is your Cl minus and K plus ions. Now if we are applying any electrical excitation, so then what happen, the inside and outside of the cell membrane. Now if you want to applying some electrical excitation, so here a cell is excited and generated an action potential, ionic currents begin to flow. So if you are applying some electrical excitation in this direction, now here so plus are enter into the inside. Now this minus it will be come out outside of the cell membrane. Your ionic current start to flow. This process excitation, so neighboring cells or adjacent area of the same cells. A nerve cell with a long fiber may be action potential over a small segment of the fiber, but it is propagated in both directions from the origin point of the excitation. Now here what happened, if you are applying some external force, now it will start from this direction, it is an origin. Now this direction, both directions, so it is also another origin. So now your electrical excitation it will be starts from the both directions. Now in most of the nerve cell the propagation rate or the range from 20 to 140 meters per second. So that is one of the important. Second, propagation of rate of the heart muscle is very slower in the range 0.2 to 0.4 meters per second. Another one is the atria and ventricles of the heart wall special cells, which the propagation rate is a very slow 0.05 meters per second. Now how the electrical so excitation it will be start to flow. So in normal ionic current it will flow from your fiber, so that your ionic current flow cell excited and generated, and then action potential this process excited neighborhood cells. So neighborhood cells means, so now this is your minus cell, now this is your plus cell. So this cell it will move into this position, this cell it will move into this position, this cell it will move into this position. Same plus ions, this cell it will move into this position, this cell it will move into this position, this cell it will be moved into this position. So these all are the neighborhood cells. The nerve only a small portion of the fiber undergoes the transition. The charge distribution has closed path. The current, the flow of these currents depolarization the membrane in the general active region, so it will becomes very activated. So if the current pattern following so behind active region is unable to re-excite again, so the active state of the membrane is remaining only for the short duration. This time After depolarization, the membrane repolarizes completely. This way, the action potential propagates along the length of the fiber. So now entire length of the fiber. How the action potential wave it will be propagating. For example, I am going to consider as a nerve cell. I am going to initially consider as a nerve cell here. Now this is your simple nerve fiber. If for example outside of the cell membrane is called Na plus ions outside of the cell membrane, inside is called as a Cl minus and K plus ions are present. If one cell it will be, if for example if I'm going to consider in this case, if this cell if this cell if these all are the positive ions, now these all are the negative ions, what are the charges from each and every cell membrane? If for example first one is a 0 millivolts, second one is a minus 10 millivolts, and third one is a minus 20 millivolts. Now inside of the cell membrane, so now it is your minus 90, and next one is a plus 80, next one is a plus 80, and last one is a plus 70, and now third cell is a plus 70. Now these are the own voltages. If I am going to applying some external force, for example in this direction I am applying some external force into this cell membrane. So what is the differential voltage? Now this differential voltage is differential voltage in normally in this case differential voltage this minus and this value, and another this minus and this value, and this minus and this value. So you will get the differential output voltage. If for example differential voltage is equivalent to 0 plus 90, now this minus of minus 90, now you are getting the 0 plus 90 millivolts. And second differential output voltage, so second one is a minus 10 plus 80. Now second differential voltage is minus 10 plus 80. So that is your second differential output voltage. So what about the third differential output voltage? So third differential output voltage is equivalent to minus 20 plus 70, minus 20 plus 70. Now this is your differential output is. So final initial what is the voltage, later what is the after applying the excitation, so what is your output voltage? If I am going to initial initial voltage of the cell membrane after applying the excitation, so what is your output voltage? So initial, if this is your cell membrane, now inside this is your cell membrane, so I am applying the 0 in this, and second one is a minus 10, and third one is a minus 20 inside of the cell membrane. So we have minus 90, and second one is a plus 80, and third one is a plus, I'm applying the plus 70. So what is your output is a differential output volt. First one is first differential output voltage is a plus 90 millivolts. Second differential output voltage is minus 10 and plus 80. So you will get the 70 millivolts. And third differential output voltage 3 is a now minus 20 plus 70. So you will get the 50 millivolts. The propagation of your reaction potentials it will be considered. In this case, the propagation of your reaction potential is considered your output voltage is a 90 and 70 and 50. But initial what is the output voltage? Minus 90 and plus 80 and 70. This is your initial. So there is a difference. So because the reason is after applying the excitation, your neighborhood of the cell membrane is also disturbing its original positions. This region. So we have to be considered now the action potential of nerve cell. So what is the action potential of the nerve cell? Now in this case the action potential of the nerve cell is seems like this. In x-axis time period, x-axis, so that is your millisecond. In y-axis is a millivolts, so y-axis is a millivolts. Normal, if you are applying some external pressure, so then you will get the Magellan potential. So now it is your Magellan potential waveform, it will be seems like that. Okay, now it is a 0 point it is a 0.1 a millisecond. Another one, this is your 0.2 millisecond. Now this is millivolts is a 10 millivolts, 20 millivolts, 10 millivolts and 20 millivolts and 100 millivolts and so on like that. So now we will move into the second one. What is the action potential of Magellan cell? So if you want to see this action potential of the Magellan cell, so then what is your output waveform? Now the time period in x-axis, time period, so that is in a milliseconds, and in y-axis is a millivolts. Now it is a 10 20. After applying the excitation, what is your action potential output waveform? Your output waveform will be seems like that. Action potential of your human being Magellan cell, it will be seems like that. It is your plus 20 and it is 30 and it is your 40 millivolts. In x-axis it will be seems like that 5 milliseconds and 15 milliseconds and 20 milliseconds. So this is the way of the propagation of your action potentials.